All right, so we are going to use DeMoivre's nth root theorem to solve -8 to the 1/3 power, or the cube root of -8. So this is DeMoivre's theorem here for the nth roots, and what we're saying here is if we wanted to find, for example, -8 to the 1/3 root or to the 1/3 power, we could use this theorem here. And in order to apply this, we need to figure out what r is, what n is, what theta is. And we also have k in here. So k is going to stand for these different values, 0, 1, 2, 3, and whatever root we're looking for. So for example, we're looking for the 3rd root. We are going to go to, the k is going to go up through n minus 1. So if we're figuring out the 3rd root, n minus 1 or 3 minus 1 is 2. So we would go through this whole thing for k is 0, k is 1, and k is 2. When we're trying to solve for this, we're going to follow these steps. If the number isn't written in complex form already, and our number's not, so we can rewrite it using the imaginary part, we'll write that in complex form. And then we'll graph it to get an idea what we're looking at, figure out r, then find the value of theta, find the value of n, and once we have all of those things, then we can apply the formula to figure out the different roots. So here we have -8 to the 1/3 power, or the cube root of -8. So the first thing we want to do, again, is we want to write it in complex form. So remember, a plus bi is complex form. This is the real number part, and this is the imaginary part. So over here, we have -8 as our real number part, and our imaginary part is 0. So we'll rewrite it as 8 plus 0i. All right, the next thing we want to do is graph it. So if this is our coordinate plane over here, we're going to make this the imaginary axis, and this is our real number axis. So -8 would be 1, 2, 3, 4, 5, 6, 7, 8. -8 is over here in quadrant 2. So this is quadrant 1, and this is quadrant 2. And because our I is 0, we are not going up at all on the imaginary axis. We're just flat on the real number axis. Okay, the next thing we want to do is we want to calculate r. And just in case you're not really clear on what that r stands for, it's hard to see here because we're on the real number axis. Let's step back for a minute and let's pretend that this was -8 plus 5i, just so you can get an idea what we're doing. 1, 2, 3, 4, 5. So that would be -8, 5i would be this point right here, and it would stand for this triangle. So this would be theta, this would be 8, this would be 5, and this would be our radius, or our r. So because in our case here, we have -8 and no height on that triangle, we don't see a triangle. But we can solve for r using the formula. R equals the square root of a squared plus b squared. So for us, our a is -8, so -8 squared plus 0 squared. So square root of 64, so r equals 8. So now we know that our r is going to equal 8. Let's figure out our theta next. So theta is the measurement of that angle. And you might know it right away just from looking at this, but just in case it's not clear, and so you know the steps for another one where it's not laying right on the axis right there, let's go through this. So if you remember from the unit circle, when we have our unit circle, our x values stand for our cosine, and our y values stand for the sine, and our tangent is y divided by x. So in our case here, we have a y and an x. So we could say the tangent of theta is going to be equal to our y divided by x, or in our case, it's 0 divided by -8. So that's 0. So the tangent of theta equals 0. So the arctangent, I'm going to write it this way, of 0 will give us the value of the theta. And if we plug that into a calculator, you can see that that comes out to be 0. So theta is going to be 0, 0. A little tricky here though, because we are dealing with the second quadrant, not the first quadrant. Remember, 0 is our reference angle. So if we had 1, 2, 3, 4, 5, 6, 7, 8, if we had been over here at 8, then we would say, okay, our angle is 0 because we didn't come up off the axis at all. But we're in the second quadrant, so we have to kind of picture this coming all the way over here. So our reference angle is 0 because we're not up from the axis at all, but we actually went pi way around. So the measurement for theta here is pi. So theta is pi. All right, so now we know that our r is 8, our theta is pi, and we know that our n is 3. So n equals 3. All right, so now we have enough information. Now we can go ahead and plug these in to figure out the roots of -8 to the 1/3 power. All right, so right here I've written down the formula we're going to use, and I left blanks in the parentheses because we are going to use different values of k. We're going to do this 3 times. We're going to do it once when k is 0, once when k is 1, and once when k is 2. And remember, we're doing that 0, 1, and 2 because we have to do it to the we have to do n minus 1 for the k values. And since n is 3, 3 take away 1 is 2, so we're going to do it for the 0, the 1, and the 2. All right, so I'm going to start with the 0. So let's plug in 0 for our k values for this first time through. So 8 to the 1/3 power is 2. And you can see here, this whole thing is going to go away because 2 times 0 is 0, times pi is 0, divided by 3 is 0. So this is going to end up being just cosine of pi over 3 plus I sine. And same thing, this one's going to go away because at 0, pi over 3. All right. And a way we can rewrite this, you might have seen this before, is we can rewrite this as 2 CIS, or cosine plus I sine pi over 3. So this is a shorthand way of writing this. If you see the CIS, that stands for cosine plus I sine in whatever value, and we have pi over 3 here. So our first root here is 2 cis pi over 3. All right, now let's do it for our next value of k. So our next value of k is 1. So we'll put 1 in for our k values. Again, the cube root of 8 is 2. And we have cosine pi over 3 plus, and now this is going to be 2 pi over 3. And then plus I times the sine of pi over 3 plus 2 pi over 3. And we can clean that up. So it's going to be 2 cosine, and when we add these together, we get 3 pi over 3 plus I sine 3 pi over 3. And you can see again, we can simplify those further. We can say 2 cosine pi plus I sine of pi. All right, and you might remember from your unit circle that when we're finding the cosine and sine of pi, we actually have, let's look at this, pi is over here. So our cosine is -1 and our sine is 0. So we can simplify this further. So our cosine of pi, so this is 2, and then the cosine of pi is -1, and then the sine of pi is 0. So this is going to turn into 0 over here. And distributing that out, 2 times -1 is -2. So our next root is -2. All right, and so our last root here, we're going to do it for 2. So I'll plug in 2 for our k's. So Third root of 8 is 2. Cosine pi over 3 plus 4 pi over 3 plus I sine pi over 3 plus 4 pi over 3. All right, cleaning this up, this is going to be cosine of 5 pi over 3 plus, over here, I sine 5 pi over 3. Right? And we can rewrite this as 2 cis 5 pi over 3. So our third root is 2 cis 5 pi over 3. All right, and so that's how you apply DeMoivre's theorem to find the nth root of a complex number.